I'm here with Cody from Deep Trekker to talk about a new underwater ROV that Deep Trekker's launching. Cody, good to chat. Tell me about Spectra and who is it for?
This Spectra, it's our brand new next generation ROV, really aimed at high current, tough environments. So offshore applications, naval applications, anywhere where you've got a lot of current, you want to carry a lot of stuff, this is going to be a great platform for you.
And then what's the background with Deep Trekker? What's brought you to this space and this product now?
Yeah, we started with a little essential toy, so a little ball that would spin around in the water. It would cost only a few $1,000s. We sold thousands of those machines, but it was very much aimed at more recreational, simple applications. And now you fast forward to 16 years later, and we're really doing some grown-up things. We're heavy into industrial, commercial, defense applications now, doing a lot more complicated missions and making them way simpler with this machine.
So what category does this fit in? Because it's not tiny, it's not huge, but it is kind of in the small, medium space. Talk to me about where this fits and maybe what some of the challenges are in this form factor.
Yeah, so the mini ROV market's a big market. There's lots of mini ROVs out there. Mini ROVs are great for deployment. It's super easy to get them in the water, but the problem is once you're in the water, you can really struggle. You can really, whether it's high current or just carrying lots of tools. So what you need something is that is reasonably easy to deploy, but most importantly can do the job. And this one is meant to be able to fight a lot of current and be able to hold position and take on the tough tasks.
Yeah, so what are the challenges that this smaller category tends to face there? You mentioned current, for example. I know that's one of them.
Yeah, so small ROVs really struggle with being able to contend with offshore currents. They also struggle to be able to carry a heavier payload and be able to hold it precisely. So you can imagine, say, take a task like corrosion monitoring. If I wanted to see the thickness of steel on an offshore structure, I'm going to need to clean a little area, I'm going to need to place a probe precisely, hold it there for a second, do this all while you're facing splash zone current. It can be quite difficult on a little machine to be able to do. So what this is tackling is small enough to get in the water by a man, but be tough enough and big enough and powerful enough to be able to handle those precise applications really well.
What are the specs then that matter in terms of things like range, in terms of depth, payload, all of that's good stuff?
Yeah, those are always the classic questions. So we've got the depth, this one can go to 1,000 meters, so that's triple what we could do in the past. The thrust power is always a big question too. We got 40 kilos of thrust, so it can carry quite a lot of weight. And then the big one's speed. Everybody loves the speed spec. So mini ROVs are always biased to go forwards. Everybody brags about their forward speed. Our forward speed's pretty good, it's 4 knots. But the big one's the lateral speed. Lateral is critical because that's where your current's coming from. It's not always straight on. I need to be able to hold position against any direction. And so this one can hold against 3 knots in any direction, and we've already tested that, proven that in flume tank certification settings. So
let's have a look at this Spectra that you've got here. There's an array of sensors and some proprietary technology on here. Tell me what it is that we can see.
Yeah, so the real smarts of the vehicle and the special part is right here on the head, this rotating head. What you've got here is a stereo camera. So what the stereo camera enables me to do is to be able to take really precise models of structures and get an idea of the measurement of defects. And then we've got the 3D sonar. So what this is doing is it's starting to paint a picture of the environment around you. I can build up a model with sparse point cloud, which is really critical for navigation.
Okay, and there's lots of talk about AI and digital twin and edge in this sort of space. Lots of buzzwords, but what are the innovations in that sort of area that you think are most important to your customers?
Yeah, I think that the subsea space is definitely different than other robotic spaces, and that we're still figuring out how to build 3D models reliably. A lot of people are pushing down the road of AI, but before we get there, we have to understand our 3D environment really well. And in order to do that, we need to build the 3D model in a way where any user could pick it up and build it. And that's where we're really reaching with this, is we're going to be able to build sparse point clouds, but then also nice, precise 3D models for people to be able to measure, to be able to interpret their environment, and then you add all in your fun AI stuff.
And then finally, where do you see this? For who? And in what sort of applications do you see Spectra making the most impact?
Yeah, the big 4 that we see is, one is offshore, so being able to do metrology, doing change over time, structural inspections, that sort of work. Cable inspections is another example. Also see it in defense. So we do a lot of work with explosive ordnance disposal teams.
Okay.
Now being able to have something that's rugged and big enough to carry multiple disruptors to be able to not just find the mines, but neutralize them. And then also fish farms and environmental surveys. Any sort of bottom survey where you want to carry some sophisticated sensors, this is a great tool.
Yeah, and on that point, there's a whole host of attachments that you can get for these as well, aren't they? That's kind of the bolt on. Cody, we'll leave it there for now, but thank you very much indeed for chatting us through the Spectra here, and really all the very best with the launch.
Thank you very much for stopping by.